I'm going to talk about rational functions. And rational functions, the way we're going to define them is they're where you have y equals or f of x equals, and you have a polynomial on top and a polynomial on the bottom. Now you might not remember what a polynomial is, but an example of a rational function might be y equals x squared plus 3x minus 4 divided by x plus 7. Something like that, where you have kind of an equation, a normal equation that you think about on the top and another normal equation that you think about on the bottom. But you do have this fraction. And what happens is when you have this, there are some significant things that oftentimes come about. Lots of times with rational functions, when you graph them, there is some kind of a horizontal asymptote, might kind of go across like this. I'm just drawing it pretty arbitrarily in there. And then there's a vertical asymptote that kind of goes like this. Then what happens is you get a graph that kind of goes like this, and another graph that goes up here. So it kind of splits because these asymptotes, remember, those are the walls and the ceilings. Now the one other thing that might happen on them is you might get what's called a hole in there. Okay? So there's some significant things in that we need to look at in these. We got holes. We got horizontal asymptotes. We got vertical asymptotes. And then we have what's called intercepts. We have this value right here on this particular one would be an x-intercept. And then this value right here on this one would be a y-intercept. So intercept meaning you're either crossing the x-axis or you're crossing the y-axis. Remember, this is the y-axis and this is the x-axis. So the x-axis crosses the x-intercept, the y-axis crosses the y-axis. So those are the kind of the things that we have. So let me go off and explain where each of those, how each of those works out. So the first one, we'll talk about the intercepts, because I think those are maybe the easiest ones to kind of maybe get your head around. The x-intercept, so that's where a graph crosses the x-axis. So in this case, that's when y is equal to 0, because it hasn't gone up and it hasn't gone down. It's literally sitting on the x-axis. In this case, for rational functions, what you want to do is you want to set the top equal to 0 and solve. So that's what we're going to do. We're going to set the top equal to 0 and solve. Then we got the y-intercept. So this is where the graph crosses the y-axis. This is where x is equal to 0. For a rational function, what I want you to do is I want you to substitute 0 in for x and just calculate. Okay, so just substitute 0 in for x and then calculate the y value. Okay, So then we get to some other things where we get some horizontal asymptotes. So let's talk about that first. I think that's the next easiest thing to talk about, horizontal asymptotes. Horizontal asymptotes, remember, there's three cases. The first case is if the degree, remember that was referring to the highest power, is bigger on the top than on the bottom. What happens is you have no horizontal asymptotes. Now the next thing that can happen is the degree, again that's the highest power, is bigger on the bottom than on the top. The horizontal asymptote is y equals 0. So it's a horizontal line. It's really, remember that's really the x-axis is what that is. Okay, so that's the x-axis. Now, the next thing that you have, the last thing, is if the degree is the same on the top and the bottom. What you're going to look at is the horizontal asymptote is y equals the number in front of highest power divided by the number in front of the highest power. And I will go through an example in a different video showing you how to do this, but writing these down is a super important thing, and then we'll look at a couple of examples. Okay, so we dealt with horizontal asymptotes, we've dealt with x-intercepts and y-intercepts. Now we're going to deal with vertical asymptotes. And so in a vertical asymptote, what happens is what you want to do is you want to find the x value that makes the bottom 0 and the top not 0. So oftentimes it's going to be helpful to factor this. Okay, so it's going to be really helpful to factor what you're looking at. So kind of a hint is going to be to factor the top and the bottom if possible. Then you can once you do that, we can figure out what the bottom is that's going to generate a 0 on the bottom. The last thing is a hole. And a hole happens when the top and the bottom have the same factor. So when the top and the bottom have the same factor, then the the x value that makes it 0, the x value that makes the top and the bottom 0 generates what's called a hole. So let me show you a couple of examples on the next video. And that'll make more sense. But make sure you have all these notes down so that you can add to them as you're going.